So good morning, everyone. Thank you for being here today. I see that people are still connecting, but let me just go ahead and introduce myself and introduce my team that is here in the training with me. So my name is Diana Miller, and I will be your instructor today for the OLI Studio Scale Chem course. So today we'll be just learning how to use the software and the mechanics, how to enter data and interpret the data. With me is here today my colleague Leslie Miller. She'll be in the chat. If you have any questions, just simply, you can either use the chat or go ahead and unmute yourself and ask the question. But if you put your question in the chat, she will be able to reply to your questions in the chat. And I also have my colleague Jim Berthol. He's also here. If you are having any problems with the license of the software or maybe an error message due to the license of the software, he will help us with that as well. So also make sure that you put that question in the chat so we can help you to solve that problem. Okay, so with that, I see that most people have audio or are already with audio. So what I'm going to do now is I'm going to start sharing my screen. Perfect. Just get this out of the way. And this out of the way. Okay. Could you please let me know if you can see my screen?
Yes.
Perfect. Thank you so much. Put this here, the list of, okay. So as I said before, this is the OLI Studio Scale Chem Modeling Basics. And before I start, I just want to make sure as a quick note to mention that the results that we are going to obtain or that I show during the simulations will be obtained using the OLI Studio version 11. So if you are using a slightly older version of the software, you probably will have slightly different results. So, and that happens because every time that we are doing a new release, we add new chemistries, and that slightly changes some of the results. And so it doesn't mean that you're doing something different. It's just that it could potentially be that the different version is just has different chemistry, and that's why you're having those results. The other thing is that we will be recording this session. So if you have confidential data, confidential topics or data, just make sure that you're careful with that, because we will be recording this session, and this will be public content. Okay, these are the objectives of the course, and really the main objective for me, and the one that is most important for me, is that at the end of this class, you will be able to simulate an issue that you see in the field and reconstruct it in the software, and also learn how to interpret the results of the simulation. So I want you to become very comfortable entering the data and learn where to find information and how to interpret critical information that the software is providing to you. So the training today will be divided into 2 sessions, 2 days, today and Wednesday. And every session, it will be 3 hours. And we will work for 53 to 55 minutes and take short breaks between sessions, or between sessions of the 53 to 55 minutes. And now, if you are working with 2 screens, that is ideal. But if you have only 1 screen, I would recommend to split your monitor, your monitor to see both my presentation and also to see your work using the software at the same time. So how do you do that? You will go to your Windows key and then select the left arrow or the right arrow just to share, to divide or split your monitor. The materials that we need for today are simply the software. We'll be working with the MSc SRK framework. Okay, so any version that any version that is above 9.6.3 would have access to the MSc SRK. If you have a slightly older version than this, probably you will have only access to the MSc framework, and that's okay. But in some cases, probably you will not see the same result. So just make sure that you have a slightly or a version above 9.6.3, since we will be using with this specific thermodynamic framework. We will, I think my colleague Dira, she shared with you the manuals of the software for ScaleChem, and we will walk through the essence of the chapters of the manual to learn how to enter and create objects in the ScaleChem software. And also I'll also share these slides with you, so you have them as reference. And we will also share the recording of this class. This is the course agenda. These are the topics that we are going to cover today. We will cover chapters 2 to 6 from the manual, and in the next session we will cover chapters 7 to 9, probably 10. Usually I try to make a point to finish with a chapter 10, but usually that's not the case, but I'll do my best. So like I mentioned before, if you have any questions, you can simply unmute yourselves or use the chat if you have any questions, and my colleague Leslie will help you with that. And at the end of this course, you will receive a certificate of completion along with a link to complete our course survey. And this survey will help us to rate this class and help us to improve it and make it better for future attendees. So we will appreciate if you complete this survey at the end of the class. This is the contact information for support at OLI Systems. So if you have any questions, you can reach us through the web, through the portal. This is a new portal where you can create an account and submit all your support questions, chemistry questions, installation questions, or how to use the software questions, etc. Or you can simply call us to this number. This is the direct number for technical support at OLI Systems. Okay, so that was the intro. Is there any questions so far? I see maybe someone is. Okay, so let's get started with the class. So what is OLI Studio ScaleChem? So OLI Studio ScaleChem can be seen as an add-on of the OLI Studio suite. This OLI Studio is the umbrella that contains 3 different tools. We have the Stream Analyzer tool that helps us to study the chemistry of a specific stream, process stream. what happens if I change the pH, what happens if I change composition, etc. Then we have the ScaleChem tool, and this is the tool that will help us to predict mineral scaling, if we will form scaling, in which location of production the scale will occur, how much we will be produced, how much or what is the potential of this scale to be formed, etc. And then we have the corrosion analyzer, and the corrosion analyzer will be based on the chemistry that we have created, that we have created in the stream analyzer. So let's say you have a sodium chloride solution and you want to understand the corrosion rate of a metallic material. So then you will bring the corrosion analyzer tool and calculate the corrosion rates based on the stream solution. But today we are going to talk about only the ScaleChem. And that ScaleChem tool is a comprehensive thermodynamic tool that, like I mentioned before, it helps us to predict mineral scaling, the scale, mass, and location during oil and gas production. Since in this software, you can also enter different analyses, such as gas analysis, oil analysis, brine analysis, and also saturate with solids. This tool will help you to compute the properties of these mixtures. And this will give us a representative fluid for then to then use it to predict mineral scaling. And you will be able to quantify the risk of unexpected production problems. And this tool will help you to make production designs and treatment decisions. Okay. So we can go ahead and open the software. So we will start with the software. Let me just close this here. I'm not going to save this. See if I can minimize this. Sometimes I can. And you're going to go and look for the icon OLI Studio. Like I said, I am using version 11. So just go ahead and double click to open the software. And first, when you open it for the first time, this would be the user interface that you will see. Now, let me just bring this again. Okay, so the first window that appears is the OLI Studio Desktop user interface, and I'm going to maximize this so that I cover the presentation there. So this user interface has different parts, and it will help you, or it provides to you the environment to create, analyze, and interpret the results of the application chemistry that you are entering here. So as the big picture here is, you have a navigator panel to the left, an actions pane to the left. We also have a plot template manager. Down here you have what we call the calculation output. And in here is where you will see all the warnings. Could be errors. It could be the warnings that the software maybe is assuming something and it needs to let you know what's going on. Or even if you have completed the calculation, it will give you a message saying that the calculation has been completed. You also have the tools bar up here. We will be using this tools bar a lot today. And we also have the menu bar. Okay, and we'll also see in all our calculations and so a summary table in all calculations that we do. Then we also have the navigator panel will be one of the windows that we will be using a lot. You'll see that in the navigator panel is where all the documents of the simulation will be seen. So for example, this first document that we have open here, or by default has been open, is called document 1. And we can change this name. Let's say we want to name it ScaleChem Training Day 1. So to change this name, we are going to go to File, Save As, and look for a location where you want to save your files. I'm going to save my file under my trainings. So I'm going to look for training, ScaleChem. Then I go to training 2021, and I have already created a folder for that specific training. So in here, then I'm going to save or change the name to ScaleChem Basics, or ScaleChem, maybe ScaleChem Training. Oops, can I type today? Day 1. Okay, so save. Notice that now the name of the file has changed here. Let's say you also want to create a new file. So let's click on this new file here. So the second document has been opened here. And you could create a third one. So what I want to show here is that you can always go back and forth different documents in the Navigator panel. Okay? That's one of the advantages of this Navigator panel here. The next thing I want to do is, every time that we are working in the software, it's important, or is highly recommended, at least I recommend that we use or we set up the units, the naming, and the thermodynamic framework that we are going to use for all the calculations. Okay, so for this specific training, I want to show you the units and the naming that we are going to use during the whole class. Okay, so we are going to select here, this is streams in the Navigator panel, and let's change the name of this. Let's change, instead of streams, double click on it and change to Scale Basics. Okay, so I changed the name. The next step is we're going to go to the menu bar, okay, and we are going to select chemistry. After chemistry, we select the option model options. Okay, and in here is where we will define all the setups for our for the thermodynamic framework. But before I do this, and I think I should stop here and I will cancel this, we will go back to this. I feel like I just skipped something very important here, and is talking about the thermodynamic frameworks. Okay, so when we are working with ScaleChem, or with OLI Studio in general, you will always see that there are 3 options for thermodynamic frameworks. You have the AQ, the MSC framework, the MSC SRK framework, and the AQ framework. So then you may ask, which thermodynamic framework do I need to use for my calculations? Okay, so out of these 3 thermodynamic frameworks, which one do I use? And this slide is very important because in here I am putting some general rules where basically we can come here and decide which thermodynamic framework we can use. So the order that you see these thermodynamic frameworks here is the order that OLI has developed them. So 50 years ago, when the organization was created, the first thermodynamic framework that was created was the AQ framework. Okay, this AQ framework works, and it is the one that has actually the most species in the data banks, in the database, and it works nicely when you have water as the main solvent. So if you have water, and if that water, the mole fraction of water is more than 65%, you're good. And if the components exist in the data bank, you're good to go. You can use the AQ framework. But as simulations and industry was using more than aqueous solutions, and also water as the main solvent, then OLI had the need to develop another thermodynamic framework that will use not only water, but other type of molecule as a solvent, right? So instead of water, now maybe your solvent is ethanol or methanol, glycol, etc. So the mixed solvent electrolyte was created, and this mixed solvent electrolyte will not, like the AQ framework is telling you, the mole fraction of the water needs to be more than 65%. In the mixed solvent electrolyte, we don't have that concentration limit. We don't have it for the solvent. We don't have it if it's an electrolyte or a non-electrolyte. So this MSc framework is the one that we prefer for most chemistries, at least internally at OLI. We prefer to use the MSc more than the AQ, because it just removes these concentration limits when we are doing simulations. Then there was the need to create a third thermodynamic framework for the upstream oil and gas applications. As the oil and gas industry started to produce at higher temperatures and at higher pressures, because we are going deeper to produce fluids or produce oil and gas, then at higher temperatures and at higher pressures, then we are going to what we call critical or supercritical fluids. And we needed to have a continuous prediction from vapor to liquid to gas to critical fluids. So to do that for at least the vapor phase and the organic phase, we need to model those phases using the SRK equation of state. So we combine both the MSc and the SRK equation of state when we have chemistries, when we have upstream oil and gas applications, and the chemistries contain light hydrocarbons that are, for example, methane, ethane, propane, and when you have acidic gases, when you have, for example, CO2, this is what is causing the critical transitions, right? CO2 and also H2S. And when you require also high pressure, so anytime that you go above a pressure of 80 atmospheres or 100 atmospheres, then the MSc SRK is the thermodynamic framework that is preferred for these applications. Okay, and in today's class, we will be talking about, oil and gas production, and that is the reason why we will be using the MSc SRK framework. I hope that this is clear. If there are any questions, please let me know. So to set up the framework, so let's go back to the software. To set up the MSc SRK framework, so if we click here in the ScaleChem Basics stream, we can go to the menu bar and select the option Chemistry, Model Options. This will open a new window. And you'll see that by default, at least in my machine, the thermodynamic framework that is selected by default is the AQ framework. So click on the AQ framework or in the drop-down arrow here.
Can you just repeat how you got there? Because I was installing the software and I missed the part, what do I need to open up to get to that screen? Sorry.
No problem. I'll do it again, yes. So we haven't added anything here. You'll see that in the navigator panel, you see the ScaleChem Basics that I name it. I just click on it. And then we go to the menu bar, go to the chemistry tab, and you'll see down here is the model options. So you just click on model options.
Thanks, I got it.
And yes, and then a new window is open. And in here, you'll select, so by default, at least in my machine, is AQ. So I'm going to select the option MSc SRK. So click on the AQ and then select MSc SRK. And when you select that option, you'll see that to the right, there are two data banks that are selected. You have the MSc SRK and the MSc. And that's correct. You need to make sure that you have these two. If you have any other data bank here, just remove it. I don't want corrosion. I don't think we will be using it. The geochemical, nothing like that. When you add extra data banks here, it's because maybe you are missing a component in your chemistry and maybe you are adding it as an extra data bank. Or maybe you are doing, let's say, you select the geochemical, for example. So it's because there are solids that take thousands of years to form. So maybe you want to include a geochemical data bank as part of the calculations. Okay, so there are reasons why we have some available data banks here, but for this training, there is no need to add any of those data banks. So make sure that you only have these two. Okay, so there is where we select the thermodynamic framework. Now we click apply. You'll see that the software immediately changed the thermodynamic framework for all the calculations. This is very important to do because if we don't do it at the very beginning, then we will be constantly changing the thermodynamic framework, or maybe we forget and then get results that have errors, and we don't want that. Another thing, for redox, we're not going to change anything here. For phases, make sure that you have all the phases included. The aqueous phase, vapor phase, solid phase, and second liquid phase. And everything else by default. And then simply close. And that is, we have set up the thermodynamic framework. Now, it's important to set up units as well. So what you can do next is to go to the units manager that is represented by this CF icon and click on it. I just want to show you that the software by default has some default units for all the icons, okay, of the calculations. So by default, the software has selected metric, but you can always change this to English, for example. We have the different options, or you can always create your own units, okay? I am going to work with metric units, but I promise I will do also some examples with the English units, so we learn how to use this. So we are not going to make any changes here for the default units, but there is in here in this icon is where you access the units manager to change the default units of every single calculation object. So you don't have to constantly be changing units during your simulation. Let's cancel out of this. And I think that's it. That's all what we need to do for this general setting of my stream. Okay. So once we have done that, oh, let me just talk about this slide really quickly. This is a still work in progress. This is something that my colleague Jim and then some other colleague put together on when to use a specific thermodynamic framework. In here, it will walk you through steps of when you have a chemistry, when you have your components or your chemistry, which is the thermodynamic framework that you can select when dealing with your chemistry. And if you need to, you don't know if you need to select between MSc or MSc-SRK, there is another map in here that will guide you through that selection process. But we don't have to really use this tree today because we will be working with the MSc-SRK framework only. We already have done this. And these are the two types of examples that we are going to learn how to create today. The first example that you see to the left is an aquifer production. And we are going to study standard scaling during production. And the second type of example that you see to the right is to study fluid compatibility. This is what you will be finding, for example, in secondary or tertiary type of recovery. And we will study what happens when we combine fluids or do, for example, seawater injection. So we will cover that as well.